This video is for lesson 3-3 about converse, inverse, and contrapositive. Learning goals are to write and determine the truth value of the converse, inverse, and contrapositive of a conditional statement. In the previous lesson, we discussed conditional statements, certain type of sentences that often use the word if and then. Converse, inverse, and contrapositive are all rearrangements of that sentence, changing parts of it around. So discussing the truth value means to decide whether the sentence that we create is true or false. And then the second learning goal is to be able to write and interpret biconditional statements. These are another kind of sentence that has a particular phrase in them. Every conditional statement has three related conditionals. These are the converse, inverse, and the contrapositive of the original conditional statement. The converse of a conditional is formed by interchanging the hypothesis and conclusion of the statement. The inverse is formed by negating both the hypothesis and the conclusion. Negating means to put the word not into the sentence, or if the word not is already in the sentence, taking the word not away. Finally, the contrapositive is formed by interchanging and negating both the hypothesis and the conclusion. Here are some examples using variables to represent actual parts of sentences in words. So if an original conditional sentence is if P, then Q, again, P is representing some sequence of words, a phrase of words, then its converse is to interchange the sentence, to switch the hypothesis phrase and the conclusion phrase. That would create the sentence if Q, then P. The inverse of the original conditional is to negate the hypothesis and conclusion. That is to put the word not here and here, creating the sentence if not P, then not Q. These will make a lot more sense when we do some examples where P and Q are actual phrases of words. The contrapositive is created by taking the converse and filling in the word not here and here. So these are all sentences that will have the word if and then in them, but they're a little bit different from the original if-then sentence. Things have been changed around. Let's do an example. Question 1. Given the conditional statement, if a figure is a triangle, then it is a polygon. This first portion here, the hypothesis, that's what on the previous screen we were saying is the letter P. This part here, it is a polygon. On the previous screen, that was where the letter Q was. So again, the P and the Q are representing portions of sentences. So down here in the chart, this is our original if-then sentence. If a figure is a triangle, then it is a polygon. That is true. If the statement is false, give a counterexample. We don't need to do that. Okay, now let's take this original conditional sentence and create its converse. To create the converse, we interchange the hypothesis and conclusion. So if a figure is a polygon, then it is a triangle. We've interchanged this idea about being a triangle with being a polygon. Let's think about whether that's true or false. If a figure is a polygon, then it has to be a triangle? No, that's false. There are many polygons that are not triangles. And it says to give a counterexample. How about a figure might be a square? That is a polygon, but not a triangle. Okay, now let's create the inverse of the original conditional statement. So go back to the original. Always go back to the original when you're creating these rearrangements. The inverse is created by negating or putting the word not into the hypothesis and conclusion. So if a figure is not a triangle, then it is not a polygon. Look at the original sentence and look at the inverse. Notice the only thing different are the word not put into the two places. Okay, let's think about true or false. If a figure is not a triangle, then it is not a polygon. That's false. Again, we need a counterexample. If a figure is not a triangle, maybe it's a square, then it is not a polygon? Well, no, because if a figure was a square, then it is a polygon. So this would be a false conclusion to have here with this hypothesis. The last one to create is called the contrapositive. Go back to the original. The contrapositive is created by interchanging the hypothesis and conclusion and negating them. So it will be, if a figure is not a polygon, then it is not a triangle. Switch the idea of triangle and polygon and fill in the word not. Okay, let's think about truth value. If a figure is not a polygon, then it is not a triangle. That's true. If a figure isn't a polygon, then there's no way that it can be a triangle. If a given conditional statement is true, the converse and inverse are not necessarily true. In our example, we showed that. Our original sentence was true, but these two were not true. However, the contrapositive of a true conditional is always true, and the contrapositive of a false conditional is always false. Likewise, the converse and inverse of a conditional are either both true or both false. Statements with the same truth values are logically equivalent. Number 2, write a true conditional statement whose inverse is false. We need to think of a sentence that's true, but if we created its inverse, it would be false. Here in purple is one that I thought of. If an angle measures 45 degrees, then it is acute. That's a true sentence. Let's create its inverse by negating the hypothesis and conclusion. If an angle does not measure 45 degrees, then it is not acute. That's false. Just because an angle doesn't measure 45 degrees, that doesn't mean that it's not acute. The angle could be a 46-degree angle or a 47-degree angle or many others, and it would be acute. Okay, number 3, write a true conditional statement that is logically equivalent to its converse. So logically equivalent means that we want its converse to have the same truth value. It asks us to write a true sentence. So when we make its converse by interchanging the sentence, we want it to also be true. Here's one that I thought of. If you pass 11th grade, then you are a senior. That's a true sentence. Let's think about the converse. If you are a senior, then you passed 11th grade. That's also true. When a statement and its converse are both true, they can be combined into one statement using the words if and only if in the middle of the sentence. And if and only if statement is called a biconditional statement. And all definitions that we've learned could be written as biconditional statements. Number 4, write the definition of perpendicular lines in biconditional form. So in the middle of our sentence, we need to have the phrase if and only if. It might look like this. Lines are perpendicular if and only if they intersect at a right angle. The purpose of writing it in this form is so that we know that this definition operates in 2 directions. It operates moving to the right, but also reading it backwards. For example, if we thought of this as saying, if lines intersect at a right angle, then they are perpendicular, we would know that's also true. Number 5, consider the statement, numbers that do not end in 2 are not even. We write this in if-then form. How about like this? If numbers don't end in 2, that's this piece here, then they are not even, and that's this piece here. I've rewritten it using the words if and then. Now we're supposed to indicate whether this is true or false. Okay, let's think about this hypothesis. If numbers don't end in 2, maybe a number ends in 3, then they are not even? Yeah, okay. But what about this example? A number that ends in 4. If numbers don't end in 2, like one that ends in 4, then they are not even? Well, no, this is even. So this statement is false. And our counterexample is to think of a number 4. Question B, write the converse and state whether it's true or false. Give a counterexample. Okay, go back to the original. Back to the original. Right here is kind of the italic print. Okay, we're always going back to the original statement when we're making these new statements called converse, inverse, or contrapositive. So we want the converse of this. We want to exchange the conclusion and the hypothesis. So if numbers are not even, that's this piece, then they do not end in 2. That's this piece. You're just reversing the original sentence. Okay, true or false? If numbers are not even, for example, the number 7, that's not even, then they don't end in 2. Okay, I'll go with that. Another number that's not even, 13, then they don't end in 2. Yep, 13 doesn't end in 2. For every number we can think of that's not even, is it guaranteed that it won't end in 2? Yes, I think so. This is true. So there are no counterexamples. We weren't able to find one, and that's why we said true. Question C, write the inverse and state whether it's true or false. So go back to the original, circled here in brown. For the inverse, you're negating the hypothesis and conclusion. So it already had the word not in it. When you negate, you're removing the word not. And it would create the sentence, if numbers end in 2, then they are even. That's true. Question D, write the contrapositive and state whether it's true or false. So going back to the original, to make contrapositive, you negate them and interchange them. And that will create this sentence in D. If numbers are even, then they end in 2. I think that that's false, because I can think of a number that is even, like the number 4, and it doesn't end in 2. So that number 4 is my counterexample. Can you write a biconditional statement for the original? The answer is no. And the reason we can't is because the original conditional and its converse have different truth values. Biconditionals are when the original and its converse have the same truth value. The original sentence, again, was the one circled in brown, and then the converse was the one we had written in B. These had different truth values. Here are some check your understanding questions, so I'll pause the video. In this lesson, we wrote sentences that used the word if and then, and from an original if-then sentence, we rearranged them in different ways to create a converse, an inverse, and even a contrapositive. And then we thought about whether these statements were true or false. In the case where an original if-then sentence and its converse have the same truth value, we can write them together. That's called a biconditional. And this uses the words if and only if as the connector in the middle.